Assalamu alaikum everyone. My name is Ahmed Hantor, and today I'm going to talk about the assistive trolley. Um before actually my part is the introduction. So before I go through the introduction, uh, I will show you the cart assembly. The cart assembly was drawing by using the AutoCAD drawing, and it shows all the parts of and the component that we made our project from. Uh, so after this, I will show you how our project will be. It means the prototype exception explanation video. Hello everyone. This is how our project look if a big model. The component of our project, the first one is the push button and the motor, the belt, and the shaft. So, how it's work? When we press the button, the trolley will start moving and stop it as well by press it again. Uh, all the part is connected directly with the motor as you see here. The shaft is along with the car tires, so when the motor start working, the belt will start move the shaft and tires as well. The assistive cart assists those who face some difficulties or having disabilities to push the heavy load of the shopping cart. No worries about losing control because it's moving slow. Uh, Thank you. How our project will be if it's real. About the problem scenario. As we know, the shopping cart in major stores experienced little change and served only simple purposes ever since they were first manufactured. Pushing these cart around becomes notably painful when they carry heavy load. Even though generally people are not moving fast in stores, um, there is problem in pushing the heavy load. Moreover, product can be extremely difficult to locate before people get familiar with the store layout, and this needs the customers to push the trolley for longer period of time, which will make the customers tired and worst will be in pain. Young and healthy people will have a little problem on pushing the trolley, but to consider older and disabled customers, they will face a hard time pushing the trolley around the shopping mall. About the objective. The objective of this research project is to produce an equipment that helps old folks, disabled person to push shopping trolley in ease, to make a product which easy to handle, to reduce the initial push of pulling force of the trolley. Um, about uh, about the scoop, I will show you a few scoop and guideline to ensure that the project is conducted within its intended boundary and heading in the right direction to achieve its objective. Um, Design of assistive trolley project, designing a proper equipment for the problem stated, which is suitable, lightweight and easy to handle. uh, about the product description, this product will help user to push heavy load easily, where it will assist the user by the help of the motor move the trolley. It can be operated with a push of button, and can be stopped in case of emergency by pushing the button. The motor will start to move slowly, and it helps the user to push the trolley easier even the load as motor with the optimum torque will be used. The design of the product follows the current shopping trolley design with add components. The product is built up by several components. The component is the trolley and push button, motor, battery, and the shaft. Thank you so much. That's all.
First of all, I'd like to say very good morning to the panels. In this slide, we will be discussing about engineering analysis that has been performed to my project, which is assistive trolley. Okay, first of all, I would like to explain what is engineering analysis before going further. The definition of engineering analysis is process of scientific analytics to reveal the properties and state of a system, device, or mechanism under study. Okay, what are the list of analysis done in my project? Okay, first of all, it is material analysis. Second, we did von Mises stress analysis. The third one is safety factor analysis. The fourth one will be risk and analysis or ergonomics. In ergonomics, we did specifically ruler analysis. And the last one is Proteus simulation for electrical components in our project, which is our motor. The first analysis, material analysis, is a well-established technique used to determine the physical and mechanical properties of raw materials and components. There are two steps. For the first step, we translate the design requirement. Okay, this is the translation of design requirement for our project. Right now, I'm taking an example of handle rod and shaft from our project, where we have functions, constraint, objective, and free variables. By using this translation, we will select a suitable material. Over here, we can see another example of material translation for wheels and handle padding grid. Still the same table, we have function, constraint, objective, and free variables. Step 2 is analyzing in CES EduTech. So what can we get from CES EduTech? There are two data, important data that we can get. First of all is the material properties, and the second is the material cost. Both of these will be shown in a bubble graph. So we can take the suitable materials and we can see the price comparison between different materials. Okay, here we can see a bubble chart of fracture toughness versus hardness. It is generated by CES EduPack. On the bubble chart, we can see there are a lot of materials. How do we choose materials from this bubble chart is by going back through our translational process where we have certain needs of our material. From there, we will mark a line for over here. For example, over here is fracture toughness versus the hardness. We need a material with very good fracture toughness and hardness. So we will mark a point here and here for, and we will connect the points. Once we connect it, we will get a family of bubbles. In this case, we get metal and alloys family. Under there, we will see what material is suitable for us. In this case, we have already chosen the low carbon steel because it has a very good fracture toughness and hardness. Here we can see a table where it is also generated by CES EduPack, where it shows the highlighted point of low carbon steel, where it has a very good fracture toughness, which is of around 41 to 82 MPa. And here we can see another example from our project. We choose this material, which is polyurethane for our tire and hand grip. Over here we can see that it shows the density and price. So we use the CES EduPack material analysis to compare the material properties and material price, and we will choose a suitable material regarding on their properties and their price. The next analysis we have done is von Mises stress analysis. So let us see what von Mises stress analysis will do. Von Mises predicts the fail or yielding of material under complex load. So we have done this stress for our shaft to see whether it will fail or not for a certain load. So for our project, we have taken a benchmark load which is around 100 kilograms, and we run the test using our SolidWorks. From the test, we can see that the shaft can withstand the load, all load happening to it. Okay, another analysis we have done is safety factor analysis. Safety factor analysis is a ratio between strength of material and maximum stress impact. Uh, Over here, we can see that the indicator is in blue color. The total shaft is in blue color. Blue color means it is able to withstand the stress. It doesn't fail. If red indicator, it means it will fail. So the blue indicator means we are very good to go with the shaft material and shaft. Uh, while if you get green color, although it is good, green means over engineering. Over engineering for us is a waste. So I think so for our project we got blue color, so it means it is very good, and we can move forward with another test. Okay, the next assessment we have done is ruler assessment. So what is ruler assessment? Ruler assessment is rapid upper limb assessment. It is to calculate risk of muscle loading within upper limb and neck. We have done this because for shopping cart or shopping trolley and for our assistive trolley, ergonomics is very important because we are solving problems regarding on the weight, and we are helping people to push the weight, heavy load, and we are more focused on older people and disabled people. So this assessment is very important for the ergonomics. So we did two assessments. For the beginning, we compared the assessment using conventional trolley, which have a shorter wheelbase, and it has a shorter height. So when we did the assessment, we get the overall score of 7, which is very bad because it is according to ruler assessment. 7 will give uneasiness and it is not comfortable to use. So from that from that assessment, we did some modification to our own project, and once the project is done, we did another assessment using our project, and we get overall score around 4. Overall score 4, it means in ruler assessment it is very comfortable and safe to use. Okay, this is an example of ruler assessment done by my friend. Okay, for the last slide, for the last analysis, what we did is plotting simulation. Over here we can see plotting simulation is basically a simulation for electrical components. It shows whether the electrical circuit is working or not. So this simulation shows that our electrical circuit is working and the motor is spinning. And that's all for engineering analysis. Thank you.
Cost analysis. A break-even analysis is a financial tool that lets you decide how profitable your company or a new service or product would be at. In other words, it is a financial calculation to determine the number of products or services a company should sell, particularly fixed costs, to cover its costs. Analyzing different price levels in relation to different demand levels, an entity uses break-even analysis to determine the level of sales required to cover total fixed costs. The concept explained above may be presented as follows. A. When there is a profit, revenues is greater than variable cost plus fixed cost. B. At break-even point, revenues is equals to variable cost plus fixed cost. And C. When there is a loss, revenues is less than variable cost plus fixed cost. Determining costs and prices. First, fixed costs. Fixed costs are also called as the overhead costs. These overhead costs occur after the decision to start an economic activity is taken, and these costs are directly related to the level of production, but not the quantity of production. This is the table for fixed expenses per month, and you can see After all the calculation, total fixed cost in 1 year is equals to 181,800 ringgit. Second is variable cost. Variable costs are costs that will increase or decrease in direct relation to the production volume. This cost includes cost of raw material, packaging cost, fuel, and other costs that are directly related to the production. Calculating the variable cost, these variable costs are those that will fluctuate together with production volume. And from this table, we can conclude that the total price is 401 ringgit. And this is the calculation. A, total cost is equal to fixed cost plus variable cost, and the total is 15,551 ringgit. And B, price of selling the product is equal to 500 ringgit. Contribution margin means a measurement of the profitability of a product. It can be shown as a ratio. Contribution margin can be calculated for a product line using total revenues and total variable costs. First, unit contribution margin is equal to sales price minus variable cost, and the total is 99 ringgit. And B, contribution margin ratio is equal to unit contribution margin divided by sales price, and we get 20%. And C, break-even point is equal to fixed cost divided by unit contribution margin, and this is the break-even chart, and the total is written there. Sustainability, environment, and safety consideration. We all know what we need to do to protect the environment, whether that is recycling, reducing our power consumption by switching electronic devices off rather than using standby, by walking short journeys instead of taking the buses. It defines how we should study and protect ecosystem, air quality, integrity, and sustainability of our resources, and focusing on the elements that place stress on the environment. The definition of sustainability is the study of how natural systems function, remain diverse, and produce everything it needs for the ecology to remain in balance. It additionally recognizes that human civilization takes assets to maintain our present-day lifestyle. Sustainability is not just about the environment, it is also about our health as a society in ensuring that no people or areas of life suffer as a result of environmental lawmaking. First, material. The process of product design is a way of creating brand new product and very passionate. New materials are presented every day, and some materials are just advancing into a whole different level. In the making of new product, selection of material is as important as it can be because the properties of its own materials. Second, manufacturing process. Green manufacturing is a term used to describe manufacturing practices that do not harm the environment during any part of the manufacturing processes. It emphasizes the use of processes that do not pollute the environment or harm consumers, employees, or other members of the community. In green manufacturing, environmental impact of all stages of production is considered. The manufacturer will not use materials which are harmful to the ecosystem in the design, production, field application, and end-of-life disposal stages of the product. In our prototype, there are 3 manufacturing processes that involve which are forming, joining, and machining. Those processes do not involve any chemical process, thus it is safe for the user and for the environment. Thank you.